So let's get started. First off, thank you for joining the webinar today. You'll know that we're going to be looking into how you can get the most from Solidworks by leveraging your CAD into other areas of your business through the 3D experience. I'm sure you're all well aware that Solidworks is a dominant and very capable design tool for a large portion of the electromechanical design, engineering and manufacturing markets. It's established itself as a clear industry leader since its inception in 1995, and its features, capabilities, continual improvement and user community too are pretty much unrivaled. But I'm probably preaching to the choir a little bit here. So the principle of the webinar today is to acknowledge that Solidworks is a great CAD tool, but then we're going to explore how we can bring in a step change in efficiency to be able to utilise our CAD for the wider business out of the design office and into things like procurement, quality, manufacturing, production and beyond. As I'm sure you'll know, Solidworks is a product made by Dassault Systèmes, and in recent years a big focus of Dassault has been to find a way to improve connectivity and collaboration between all these functions, essentially trying to join the dots between every facet of your business so you can work as efficiently as possible. It's simple: the more efficiently you can carry out your work, the less cost you incur and the more profitable you can become. Now, Dassault haven't been the only people trying to improve efficiency with business processes. Undoubtedly, you'd have noticed the ever-increasing number of programs, applications and cloud solutions that have started popping up around the web. These applications are all great and offer the potential for you to make big improvements in the way you conduct specific activities, but the issue is how you then integrate this single isolated solution with Solidworks and into your wider business landscape too. Now, this is exactly where Dassault Systèmes' business platform, which they call the 3D experience, comes to the fore. The 3D experience is Solidworks' native product lifecycle management platform, integrated directly into Solidworks so you can unlock all the benefits of the platform within the Solidworks environment itself. So, for those of you who aren't familiar with product lifecycle management, or PLM as it's often referred to, it's the process of managing the entire lifecycle of a product from inception through engineering design and manufacture to service and disposal of manufactured goods. So the areas we're going to look at in this webinar to manage the lifecycle of your products in the 3D experience, directly leveraging the CAD you've created through Solidworks, will be product ideation, requirements capture, project management, which is going to include documents, CAD, ECAD, change and issue management, and the design review process too. And then we'll take all this data and use it directly in our manufacturing simulation, which will include plant layout optimization, process planning and digital work instructions. It's worth stressing at this point that what we're going to show doesn't cover all the functionality in the 3D experience platform. There's a serious amount of functionality that's been incorporated into the platform through a huge number of acquisitions by Dassault of industry-leading applications for specific business processes. But by acquiring these solutions, Dassault's been able to consolidate all their functionalities, so you don't have to worry about integrations or managing multiple systems simultaneously. You simply turn on the bits of functionality that are relevant to your business and they'll automatically be able to talk to each other. So what we're looking at in this webinar is essentially the big hitting items that will apply to 99% of businesses like yours, providing you with the foundation to really make the most of your Solidworks data, enabling you to make that step change in efficiency. Okay, so let's get started. So the first point we're going to look at is product ideation. So generally speaking, the first step in developing a new product is done outside of Solidworks. We're talking about people gathered around a table, throwing ideas at one another or scribbling them down on a notepad. It's evident that product ideation can be quite an informal process. The 3D experience puts some structure around this by enabling people to post ideas to a community wall, where community members can vote on what they perceive to be a good idea. The ideas themselves are placed directly into an ideas funnel, and the more votes or likes an idea receives, the bigger the ideas bubble appears in the funnel, indicating the community's approval. You can probably tell that this approach is mimicking what you would see on a social media channel, and Dassault's done this to ensure that the technologies that they're implementing are current and relevant to the way people communicate in this day and age. It's not just ideas that can be posted on the wall though. People can make general posts, including 3D assets, pictures, texts, or videos. They can post questions, wikis, surveys, and even tasks that they can assign to other people in the community as well. So back to ideation. With our idea posted and voted for, we're able to push it through the funnel. You're able to define how many tiers you have within your funnel too, but the last tier will be the point where we can turn the idea into a formal requirement. So by doing this, we'll be moving from the unstructured data that you'd find on the community wall to the formal and structured data that you'd directly use developing your product. So this leads on to the next area we're going to have a look at, which is requirements management. By converting our idea to a requirement, we're instantly building some definition around the product we're looking to develop, and this is exactly what we'll aim to incorporate into our design in Solidworks. Inevitably, you'll have more than one requirement for your product, so you're able to make as many requirements as you need and structure them within a requirement specification with chapters and comments throughout. One thing you might have noticed, now that we're in the structured side of the platform, is that data objects like these requirements have a lot more attributes that enable you to formally manage them. For instance, you'll get versions and revisions of all the objects to give you a traceable history of the changes you make, and you'll see the life cycle of the object too, which defines its maturity and controls whether people can work on it. So you can drill down a lot further into the data of a specific requirement by opening its details. Here you'll be able to see and edit its properties, but also identify where the requirement's used, build use and test cases, and also identify how the requirement's been satisfied. Satisfying the requirements you make for your products is something that ties directly to your Solidworks models. The features or configurations of your designs are what fulfill the requirements, which means that there's a direct link between what's in the specification and what you've actually designed. Okay, so we've had a look at the first couple of steps that will help you push the limits of how you use Solidworks in your business. As we've seen, this will enable you to digitally capture your product ideas, rank those ideas, link those ideas to requirements, and you can then have your requirements fulfilled by the features of your designs in Solidworks. And when we talk about steps within the process of developing a new product, what we're effectively talking about is following a new product introduction program, or an NPI program as it's commonly known. An NPI program breaks the process down into distinct phases like the steps we've discussed so far. So what we could do is manage the development of the design concept, its refinement, manufacturing and release process as part of a project management process, with phases that identify and manage the delivery of set tasks that need to be completed, followed by reviews to ensure everything in the phase has been successfully completed. So in the world of project management, these are referred to as gate reviews, where a go or no-go decision is taken of whether to progress the project. And this is exactly what you'd commonly do when you complete Solidworks designs as part of your design review process. Before we look at the design review process itself, let's look at how we'd follow the NPI process using the project management functionality built into the platform, which the design review will be a part of. To start, you'd build your schedule. So we'd have our phases and gates in line with our high-level NPI process, and then we'd have our tasks and milestones as children of those phases. As with most project planning applications, you can see lots of attributes against each task. Things like dependencies, estimated start and end dates, and assignees of people who are automatically notified to carry out the work when the task in the plan becomes live. But perhaps the big differentiator of the 3D Experience platform, opposed to those other project management applications, is that you can directly link your Solidworks designs and other documents and files you're managing into the platform as deliverables against each of the tasks. You can then associate the completion of the tasks directly to the lifecycle state of those linked deliverables. We'll take a look at life cycles of your CAD and documents in a bit, but to give you an example of what we're talking about here, when the deliverable linked to the task reaches the complete lifecycle state, then the task can be set to reflect that automatically, so it becomes completed too. So what that means is you haven't got to worry about updating the plan and getting the project managers to progress chase, as the platform does all the legwork for you. Completion of tasks and milestones generally relates to the phases in your plan, but what about the gates? We can see these a bit clearer in the phase gate view. As we spoke about earlier, the gates represent your review points within your project plan, which we've said a good example of is the design review. At these points, you're able to capture physical meetings, recording things like attendees, locations, dates, times, and all the things you'd expect. But more importantly, you're able to capture the decisions that are made off the back of those meetings. So you have a traceable history of why you might have gone down a certain direction for the development of your product. Typical for a design review, you'll be able to capture and respond to checklists, and you can attach your design straight out of Solidworks as deliverables for those reviews too. So that's a high-level overview of the schedule management side of your projects and programs in the 3D experience. But how is that reported and made visible to people other than the project managers? Well, the 3D experience actually has a number of built-in dashboards and metrics readers that you can use for any of your data stored in the platform. For project management, you'll get a pre-configured schedule status dashboard, which provides you with all the visual reporting you'd likely need to assess how the schedule's progressing. On top of that, there's also a business status dashboard, which reports on project data that sits outside of the schedule. We're talking about risks, opportunities, issues, budget versus actual spends, and project assessments too. Again, all the information presented here is live data managed in the platform. By clicking on a risk, for example, we can see all the details that we've captured on the executions page presented back to us. Things like the unique ID of the risk, the affected item, its title, and the risk priority number, which determines where it sits on the risk grid, and they can all be seen here. So if you were to update the details at all, that'd automatically update the dashboard. The same is true for if you were to change any of the details that you've captured in the financials page, that'd automatically update the budget versus actual spend graph. So there's a few things we should probably double back on at this point. We've seen all about the project management side of things and how you can have live visual reports running direct off of all the data, but the principle of this webinar is how that all relates to the way you're currently working with Solidworks. So let's move on to how you can save your CAD directly into the platform, so you can then link it as deliverables as we've seen, or carry out formal change, or use it for production planning, which we'll have a look at in a little bit. Let's say we've started building the first revision of our product in Solidworks. When we want to save our work, rather than saving it locally, we're able to save it directly into the 3D Experience platform. You'll notice a new tab on the task pane on the right of your window, which is the 3D Experience compass. If you click this icon, the native Solidworks integration to the platform will open up. From here, you're able to save and sync all your CAD into the platform, which will enable your wider design team to collaborate on the design. Now that your CAD is in the platform, you'll also be able to associate it directly to your project. The search functionality in the platform will find whatever CAD you're looking for, and then it's a simple matter of dragging and dropping it from the search results into the assembly that you're working on itself. With your CAD now accessible to anyone with permission in the platform, it's important to stop multiple people working on the same part simultaneously. So to do this, people within your team have to reserve the parts and assemblies, which means they effectively get locked to that person. When they've completed making their changes, they can save and unreserve the files back to the platform, where the rest of the team will be able to see them again. If we go to the properties of any part within the tree from the 3D Experience menu, we'll be able to see a few extra attributes than we'd get with Solidworks on its own. In particular, we get revision control of all our parts, and also a maturity state, which is defined by the life cycle of the part. This is something we've touched on earlier with requirements, and it's something you'll see for every object you manage in the platform. The maturity state itself governs what you can and can't do to the part. So whilst it's in the in-work state, we can obviously make changes to it, but as it's promoted to later states, like in review or approved, then the part is locked down to edits. The principle of formally managing your CAD with revision control and maturity states applies to documents that you manage in the platform as well. As your design progresses in Solidworks, you might find the need to save reference documents, for instance, like notes from design reviews, installation manuals, or other files that aren't strictly CAD. You can do this direct from the platform by going to bookmarks within your project. Here you're able to upload whatever files you need to manage And just like CAD, these are fully version and revision controlled and have life cycles that control whether the document can be worked on and whether it's approved and released for wide distribution to your suppliers, customers, or internally at your business. As with CAD, if the document is in the in-work lifecycle state and someone needs to make an edit, they simply select the checkout option, which automatically reserves the document to that person. Once the edit's been made, they then check in the document and record the reason for the edit. A new version number is then assigned to the document, giving you a full traceable history of every edit that's made to it. So we've had a look at the native Solidworks integration and how documents are managed in the platform too. One other area to look at, so we cover all bases from an electromechanical products perspective, is how eCAD is managed in the platform. So as Solidworks has a native integration for our CAD, what we'll look at now is a native integration for an eCAD solution called Ultium, which you might be aware of. So inside of Ultium, you'll notice a 3D Experience option on the toolbar where you'll be able to start a new PCB project or open one you already have saved to the platform. When you're opening a project, the My Documents tab returns PCB projects, objects you own, or objects that you're assigned to work on. You've also got the Recently Accessed tab and My Workspaces 2, which is essentially the folder structures that you can build in the platform. As we've seen with CAD and documents, everything's lifecycle managed, and you're able to open any iteration of objects at the in-work maturity state. When you open a PCB project, you automatically check out the hierarchy of the project, meaning you can navigate through the structure and make any edits that you need. Once you're done, you can then right-click over the PCB project, selecting 3D Experience and save to 3D Experience. This checks all the files back in and unreserves them from your user. If it's a new project you're saving, you can pick where in the platform you'd like to save it to, and then by selecting your hierarchy and adding a comment for the edits you've made, you can save it directly back to the platform. If you then want to open this in the platform itself, you can right-click over your project, go to 3D Experience, and then explore in the 3D Experience. From the side menu, you can see the files themselves, you can view the iterations that the files have been through, and you can navigate the project's hierarchy like you would in Ultium itself. Derived Outputs also gives you a compiled PDF of the project in its entirety. So now we have our CAD, documents and eCAD synced into the platform and associated to one another by being saved in context of our project. But everything saved against the project now is at the in-work lifecycle state. The next step then is how we promote those objects from in-work to approved. There's a few different ways of doing this in the platform, but the most controlled approach is to use formal change management. The platform enables you to build a change management process to suit the needs of your business. Whether you require a comprehensive approach, including change requests to identify the need for a change orders to govern how the change is going to be carried out, and then change actions where the physical changes are going to be made themselves, or if you just need a fast-track change process where all you're concerned with is the change actions themselves. To see the change actions, we open the Change Action app. By creating a new change action, we're then able to associate the object in the platform that we're looking to change. So, as we've said, we'll be looking to use the change action to promote an object through its life cycle to release it. We'd do that by adding the object to the proposed changes of the change action and then specifying what the change activity is. So in this case, that's to change the maturity to released. You'd then add who the assignees are to carry out the change itself, who needs to approve that it's been done correctly, and then anyone you'd like notified when the change is done. So let's say we've pushed the change through to in-work where the assignees completed whatever was needed to be done. You can then promote the change to the next state of in approval, where our approvers will get tasked to approve the change. Once they've completed those tasks, the change action will be promoted through to the completed lifecycle state, and then you'll see that we've got a realized change as well of the document being promoted to release directly linked to the change too. So we've now used change management to release our documents, CAD, eCAD and whatever else, but let's say we've noticed a problem with the released files. What we'd have to do then is raise an issue specifically against the problem we found. We briefly saw issues in the project management functionality earlier, and they're managed in the same way as a lot of objects in the platform, with lifecycle, assignees and start and end dates. But What if the issue specifically related to the CAD and we wanted to highlight the problem on the geometry itself to make the understanding of the issue a little clearer for the people working on it? Well, we'd start by going to the issue management app to raise the issue itself. From here we can capture all the details, resolution recommendations, actions taken, all that sort of thing. We'd have to pick the related object, and we can drag and drop this out of our search results. So if you've selected a bit of CAD, you'll then be able to use the Issue 3D Review app to mark exactly where the problem is. So you'll be able to move the marker to the precise area on the Solidworks part or assembly to highlight that. So the next thing to look at is how we can put our Solidworks designs into a manufacturing context. This is done by one of the 3D experience applications called Delmia. It's a bit of an obscure name, granted, but it's actually an acronym for Digital Enterprise Lean Manufacturing Interactive Application. So that gives you an impression of what we're going to be seeing here, hopefully. My colleague Kevin's going to be driving this section to show how the data can be shared across your business. So I played the role of the designer and project manager in essence from what we've seen so far, and now Kevin picks up the baton as a member of the production team. I'll keep talking through everything we see though. So with Delmia opened up, we'll have a new set of platform apps available to use. The first we'll have a look at is the Manufacturing Context Builder. From here we create the Process, Product and Resource Context called the PPR, which, when we open our design, takes us to the Process Planning application. Now that's great, but what we'd typically do first is build some definition of the manufactured items within our newly designed product and the hierarchy that they sit within on the total assembly. So to do that, we go to the Manufactured Item Definition application. In the tree, we'll see our CAD structure as before, but below that, we also have our manufactured item structure detailing things like manufacturing constraints. A good example we've got here is a button assembly that's made of two components within our CAD structure, but in the manufactured item structure, it's only one, as we've defined it as a bought-in item. Another thing to note is that each of these defined sub-assemblies have other assemblies or individual parts feeding into them. We're able to drill down the hierarchy by expanding out any element within the structure all the way to the source components as we've defined them in the manufacturing structure. With our manufacturing item definition completed, we'll then go about building our process plan. So we have these two work centres that we've put together. If we look at the tree, you'll see that there's an item below the CAD and the manufacturing definition structure, which is a work plan. Now we'd build a work plan through using the authoring tools on the toolbar here, but as we've already made one, what we can do is open up one of our work centres to have a look. Now what you can see here is a step-by-step build-up of the product in the order our production plan is defined and it should be assembled. We can open up a 3D view window and click on one of these steps to see how it looks based off of our CAD. Obviously, the further down the chain you go, the more complete the product build-up is. So this isn't just for visualizing production though. We're also able to define the duration that each of these steps will take. Clicking Process Gantt from the authoring toolbar will bring up the Gantt chart, where you can define planned durations for each activity. We can also do workload balancing, so you can see that these two work centres are unbalanced. So we could go through them and manually adjust the activities in these work centres one by one, or alternatively we could just click and drag the workloads from one centre to the other to balance them out. The activities in those work centres automatically adjust to reflect the change, so we'll undo that change, and the next thing we'll take a look at is the work centres visualised, so you can simulate the actual assembly coming together. We'll do this in the Assembly Evaluation app, and in this example we've got a couple of workbenches. It's not the best of examples as the product's pretty small, but hopefully it'll give you an idea of what can be done. What we'll do is have a look at a more extensive example of a factory floor simulation in a bit, but first we'll cover a few of the basics here. So if we expand out our work plan in the tree, we can drill down to a specific operation. This is a simple loading operation, so by pressing play on the compass we can see the part being loaded. Nothing too impressive there, but rather than looking at an operation in isolation, we can select the whole work plan, choose to show all the associated resources and visualize how the product would come together. So that's great, but obviously we need to put some definition around each of those steps so the people that are going to be doing the actual assembling of the product know what to do. We're talking about works instructions effectively. So by picking the works instruction app, we ask what we want to make the instruction about, the system itself, and what step in the work plan we want to define. So our first instruction here is of the workshop itself. We could specify tools needed, what parts you need at hand, that sort of thing. But the next step, rather than just setup, is an actual process. So we've added labels to say what needs to be done. Same with the second step, but we've also made this a data collection point. Here we can specify a check that needs to be made, and we can say who formally needs to sign it off. So with your work instructions done, you can release them for the shop floor in a standard format. Clicking the link for the individual operation within the work plan will take you to more details of that step, and that includes the 3D representation based off of your CAD as well. We've touched on communicating with the shop floor a little bit there. A bit of functionality that takes that up a level though in the 3D experience is the 3D lean functionality. It's intended for things like toolbox talks, where you've got an interactive whiteboard where your shop floor teams can gather around. From there they can look at and capture data in the platform. Inside of these boards you can configure the data that's shared so it's pertinent to whoever's viewing it. We can have a look at things like people you're expecting to see at the meeting. You can view any documents published for the meeting too. You can create things like problems logs where you can make and then drag and drop notes around to show that the problem's being managed. And then the link back to your Solidworks is that you're able to share your CAD with the shop floor direct through a viewer built into the board. With that, you're able to add notes to the model, take measurements and cross sections and that sort of thing that you wouldn't typically be able to achieve with a conventional printout. So the shop floor we saw with our product that we've used on this video so far was just a couple of workbenches. So as we said, we'll look at something a little bit more advanced now. Another app built into the 3D experience is factory flow simulation, where you build everything from the car park to the machines and equipment you have on the shop floor. You then simulate how the shop floor team will interact with those bits of kit. So here's the factory with everything modelled and in place. What we can then do is hide layers of the visualization, like the building infrastructure, so we can see the resources we've put on the shop floor. When we press play on the simulation, we'll see the raw materials arriving at each of the bins and then the products being built up. And it gives you a pretty clear indication of what's going to work in reality and lets you get an appreciation for the stock levels you're going to need of raw materials coming into the factory too. So when it comes to infrastructure investments, then you're much more likely to be getting it right first time. You're able to capture animations of production runs too, so you can quickly assess how feasible you think something's going to be. We've got an example here of some automation on a bottling plant. So what we've done now, started with our product in Solidworks and we've gone all the way through to production and visualizing and simulating how that production is going to happen. So I think that probably just about does it for the platform overview today. Like I mentioned at the start, this is by no means a full picture of what the platform has to offer, but it was to give you a quick impression of where you could leverage your Solidworks designs in the platform to streamline those transitions between functions and departments of your business, ultimately improving the efficiency of how you're working and enhancing the bottom line, hopefully. So I guess now what we'll do is we'll open up to some questions. Thanks.